Hello everyone, welcome back to AP Calculus AB. This is lesson 4 in Unit 10. This is our last lesson that we're going to have in our 10th unit, which is our last unit. So give yourself a pat on the back for making it this far. Let's get down to it. Our first problem is a practice problem. We'll be looking at finding some information out about a region. I think we're just going to stick with practice problems this whole lesson, so it should be mostly a review, but maybe a few new concepts thrown in here and there. So work on practice 4.1 about a region R, or excuse me, a region S. Okay, hopefully you've had some time to do that. Hopefully you pause the video. Remember to do that. Always very important that you practice first. We're going to find the area of region S when k is equal to 4. So the region S is bounded by the curve y equals 4 cosine pi over 12x, and the lines x equals 0 and x equals k for 0 less than or equal to k less than or equal to 6. So this purple line k is actually sliding back and forth, okay? It's moving back and forth. You can think about that. And as it moves to different locations, the region S becomes a different size. But we're going to find the area of region S when k is 4. So to do that, this is simply the definite integral because it's the area underneath the curve. And the curve is above the x-axis. So from 0 to k, in this case 4. I don't need to put k. I'll just go straight to putting in a 4. Of 4 cosine pi over 12x dx. All right, well, we know from the fundamental theorem of calculus that we just need to integrate and then evaluate at 4 and subtract the value at 0. So when I integrate this, if I let u equal pi over 12x, then du is equal to pi over 12 dx. So 12 over pi du equals dx. So this becomes the integral of 12 over pi. I'll change my bounds, plugging in 4. Pi over 12 times 4 gives me pi over 3. And 0 times pi over 12 is 0. 4, I think I'll bring the 4 out. So we'll make this a 48. How's that sound? Cosine u du. So 48 over pi times the integral of cosine is sine from 0 to pi over 3 is 48 over pi times the sine of pi over 3, which is the square root of 3 over 2, minus the sine of 0, which is 0. All right, our next question says, find the rate of change of the area S with respect to k when k equals 4. The area in S, which is bounded under this curve and the y-axis and the vertical line x equals k, can be found with the integral from 0 to k of 4 cosine pi over 12x dx. But I want to find the rate of change in this area. This is the expression for the area, so I want to find the rate of change with respect to k. So I want the dk. Well, you might recognize this as the fundamental theorem of calculus, the second part that we learned. You can tell that it's the fundamental theorem of calculus because this is dk, and they were integrating from 0 to k. All it does is change this variable x into k. See, we're integrating, and then we're taking the derivative. So this becomes 4 cosine of pi over 12k. Then it says when k is equal to 4. So we found the rate of change. Now we got to plug in 4. Very important, y'all, that you find the rate of change equation before you plug in for k. K's a change in quantity. You can't plug in until after you take the derivative. So this is 4 cosine of pi over 3. The cosine of pi over 3 is 1/2. So the answer is simply 2. 2 square units, per k, whatever k's unit is. The region S is rotated about the line y equals 5. Write an expression for the volume of this solid. So the line y equals 5 is up here. If we're going to rotate it this way, then we're going to have an outer radius and an inner radius. My outer radius is this entire length here, which is simply the distance from y equals 5 to y equals 0. So that's 5. My inner radius is the distance from 5 to the curve 4 cosine pi over 12x. So we're going to get pi, and remember it's pi r squared minus r squared times the integral from 0 to k. Our outer radius was simply 5 squared minus our inner radius is 5 minus the curve 4 cosine pi over 12x. And this is squared as well. And then the whole thing is multiplied by dx. The region S is the base of a solid with cross sections perpendicular to the x-axis in the shape of rectangles with heights equal to twice the length of their bases that lie in S. So our curve looks something like this. We're going to be using cross sections perpendicular to the x-axis that are rectangles. So these are rectangles coming out of the paper. The base of that rectangle is what lies in S. So the base of the rectangle is simply 4 cosine pi over 12x. But the height is going to be equal to twice the base. So 2b. So my integral is simply from 0 to k of all the area functions, which is 4 cosine pi over 12x times twice 4 cosine pi over 12. So times 8 cosine pi over 12x dx. All right, practice 4.2. Go ahead and pause the video. We got another application where we link what we're doing over to the velocity problems, particle motion. Okay, hopefully you've paused the video and done A through F, or at least got ready to do some of it, and feel free to pause the video, of course, in between different steps. I pulled up a graphing calculator here that I think we can use. All right, the velocity of the particle moving along the horizontal axis is given by this. Find the average acceleration of the particle over the time 0 to 4. We're given velocity, so average acceleration is asking for the average rate of change of v. Average acceleration is average rate of change of velocity. So my average rate of change formula would be v of 4 minus v of 0 all over 4 minus 0. So let's take a look at that equation. What would that be? So I'm going to do this little trick where I use the such that. So I'm going to say diamond e to the 0.4 times t plus 4 times cosine of 2 times t minus 4 such that t equals 4. So that's how I'm evaluating v of 4. So that is 0.37. Let me make this where it stays on top real quick. So that is 0.371 minus, now I just need to change this 4 to a 0, which is a 1. Over 4 minus 0. And they didn't give us any units, so we don't want to try and give them any units. All right, let's do the next one. Find the average velocity of the particle. Well, it's asking for average velocity, and we have an equation for velocity. They're asking for the average value, what I call my favorite function, fav. So the average value is 1 over b minus a times the integral from a to b of f of x dx. So this will be e to the 0.4t plus 4 cosine 2t minus 4. All that times dt. And we can just easily type that in the calculator. 1 divided by 4 times the integral of e to the 0.4t plus 4 times cosine of 2t minus 4 with respect to t from 0 to 4. And I must be missing something. What is that? Oh, I got too many zeros. My t did not, too many commas. My t did not appear. Still not working. There it goes. All right, so we get negative 1.035. That is the average velocity. All right, it says find the acceleration each time where v of t is equal to 0. So to find when v of t is equal to 0, we're going to go to our graph and type it in. Let me bring this up where I can see the equation. So my equation is e to the 0.4t plus 4 cosine 2t minus 4. And I'm going to go ahead and go to my window and just make a little bit of changes here. I'm going to say 0 to 4, and I'll make my y min negative 5, my y max 5. Undefined variable. Oh, you know what? I forgot that you can't use t. You got to use x. Wish they'd let me put in any independent variable I want, but that's probably better this way. All right, let's try that again. All right, there we go. And there it is. I need to find the 0 here, and it looks like this other one's just a little bit too far. So that's all I need to find is 2 of them. So F5 for the math menu, 0. And we have to tell it a lower bound. Lower bound means left bound, to the left of the 0. So put this to the left of the 0 that you're looking for. Upper bound means to the right of the 0. Notice that my upper bound, you might think of it as actually below the 0 if you're looking up and down, but don't think that way. Think to the right. Upper bound means upper bound on x. So that is 0.392. So v, we're going to show our work like this. V of 0.392. I'll go ahead and do one more since we're going to have to evaluate it. I want to make sure I get accurate to 3 decimal places when I'm all done. So I'm going to wait to round at the end. And F5, we're going to find the 0. To the left, to the right, and we get 2.517, which I'll do as 69 equals 0. Okay. We're supposed to find the acceleration, though. So now we need to find the acceleration at each one of these 2 points. So I'll need to use my derivative, and there's a couple different ways I could do that. I could say second derivative, and you can actually say y1 of x. You can actually type that in and then say comma x, since I already have the equation in my y1 of my graph menu. Then you say such that x equals 0.3924. If you don't want to do that, you could type in the equation and put comma t such that t equals whatever you want. So we get negative 5.185, and we'll find a of 2.5169. $8.685. All right, next it asks me to find the displacement of the particle over the time from 0 to 4. Displacement is the change in position, which is the integral of velocity. So we just need to integrate our velocity function from 0 to 4. And nicely enough, I've already got in my y equals, so I can integrate with it. Integral of y1 of x with respect to x from 0 to 4. the displacement of the particle is 8.685. What that means is that the position of the particle is 8.685 units right of where it used to be. Oh, that's the last answer. I'm sorry. I was looking at the wrong thing. Sorry, it should be negative 4.139. It hadn't finished evaluating yet. So negative 4.139 is the displacement. Now we're going to find the distance. Well, distance is the absolute value of velocity. So to find the total distance traveled, I have to use the absolute value of the equation, which was what? E to the 0.4 t, can't remember, plus 4 cosine. So just 4 cosine t, 2t minus 4. All right. All right, so I can do that here as well, but we really should use a numeric integrate. So I'm going to say F3, and it's down here at the bottom. So I press up, it comes back to it quickly. Numeric integrate, then we have to say second 5 for the math menu, number, absolute value. So I'm taking the absolute value of this function. Oh, you know what? I make sure my absolute value bars are not curly. There we go. All right, we're still busy. It's busy. Busy, busy, busy. Well, I assume it's going to figure it out. Maybe I need to give it more information or something. I don't know. Let's go on to the next one. We've written an expression for it. So let's find the maximum velocity attained on the integral from 0 to 4. So the maximum velocity is going to be when velocity is at the highest point. So we need to take the derivative of velocity and then use that to find the critical numbers, and then evaluate at the endpoints and all the critical numbers. Looks like our work is finally done here. It's 11.645. Okay, so first we need to know, when does v prime of t equal 0? Well, I'm going to show you another trick then. I've got y1 here. I can leave it there, but I can actually uncheck it so it won't graph it. See, when you highlight it, F4 is the check, so I can put it unchecked. Just make sure you check it back on when you need it. And I can graph the derivative of y1 of x with respect to x. Isn't that kind of nifty? So now I've got the derivative, and I can graph that. So I can find the critical numbers fairly easily. So it looks like there's a critical number at 0, but that's already an endpoint, so I'm not going to worry about that. And we will use our math feature to find the 0. All right, let's see here. Where is my little spider guy, little cursor? Can't find it. I think it's down here somewhere. Nope, it's up there. All right, remember, lower bound means to the left, not necessarily below. Upper bound means to the right. And don't quit till you see the word 0. I'll say 1.5247. And where else? And at t equals, let's go get that other 0. Sometimes hitting second arrow make it go a little bit faster. All right, left bound and right bound, lower and upper bound. So that happens again at t is equal to 3.2332. So now we just simply evaluated each one of these things. V of 0, V of 1.5247, and V of 3.2332, and V of 4. And the maximum, according to the candidates test, is the one that gives us the biggest value. So I can use y1 of 0, type it in just like that. I get 1. I can do y1 of 1.5247. And we get negative 0.61, negative 6.143. And now we'll try 3.2332. Oh, too many parentheses. 3.5778, something like that. And then finally y of 4. Which is 0.371. So by the candidates test, we know that the maximum velocity obtained is 3.5778. All right, let's move on to the next one. The region enclosed by the graphs of y equals x squared and y equals 3x is the base of a solid. For this solid, each cross-section perpendicular to the y-axis is a rectangle whose height is 4 times the base, which lies in the xy plane. Write an expression for the volume of the solid and use your calculator to evaluate. All right, sounds good. Pause the video and give it a try. All right, let's take a look and see how we did here. Y equals 3x is a graph sort of like that. Y equals x squared goes like this. And they're going to intersect a couple of times. I can just kind of think about it, 3, 9, and 0, 0. But if you're not sure, set these two equations equal to each other and solve for x. Okay, we want to take cross-sections perpendicular to the y-axis. If our cross-sections are perpendicular to the y-axis, we're going to have to work in terms of y's with a dy. So it says that the base of the rectangle lies in the xy plane. Well, this base here is this x coordinate minus this x coordinate. So we need to get our expressions in terms of y's. So x is equal to the square root of y, technically plus or minus, but we're dealing with just the positive side here. And y over 3 is equal to x. So my integral will be the integral of the area as some function of y dy from 0 to 9, because we're doing y coordinates from 0 to 9. So the outermost point here you can see is the square root of y minus the innermost point is y over 3 dy. All right, and then we can use a calculator to evaluate that. Lickety split. The integral from 0 to 9 of the square root of y minus y over 3, comma y, comma 0, comma 9. Which gives us 4.5. All right, let's try the next one. The acceleration of a particle traveling along a vertical axis is given by this function. If the velocity of the particle is 5.31 when t equals 6, then the velocity at t equals 2 is equal to what? Pause the video and give it a try. All right, since velocity is the antiderivative of a, we say a is the derivative of v. So this is simply our accumulation function. We know that velocity at time 2 is equal to velocity at some other time that I'm given, which is 6, plus the integral of all the accelerations from 6 to 2, which, we'll be going backwards, but that's fine. The calculator would take care of it for me. Which this is a calculator problem. I'm not sure why it doesn't say calculator, but it should. So this is 5.31 plus the integral from 6 to 2 of t squared minus sine t over t squared plus 1 dt. So let's type that in and see what that gives us. This might make a nice multiple choice question, maybe on a AP test on the calculator portion, right? So t squared minus the sine of t. That's my numerator, divided by my denominator, which was t squared plus 1. And we're going to be integrating with respect to t, and we'll be going from 6 to 2. Really want to be careful that your pretty print is absolutely spot on this question, because there's a lot to type in. All right, that looks like what I want. So it's 1.60. What is that? 7. Okay, cool. Let's try another one. The velocity of a particle traveling a straight line is v of t equals 2 times e to the negative t over 3 sine of 3t meters per second. Again, looks like a calculator question here. What is the total distance in meters traveled by the particle from the time interval 0 to 3 seconds? Pause the video and give it a try. Okay, hopefully you recognize that since it says velocity of a particle and it asks for total distance, not total displacement, but total distance, that we need to be doing an integration of the absolute value of v from 0 to 3. And this could likely take the calculator a good long time. So I will get it started. The integral, we're going to do a numeric integral, or it's just really not going to work. F3 numeric integral. And then we need to use the absolute value, which is under math. Of 12 e to the negative t over 3 times sine 3t, comma t, comma 0, comma 3. Oh, I forgot to close off my absolute value parentheses. There we go. And then close off parentheses for the numeric integration. And hopefully, after not too much effort, it can give us a numerical answer. Okay, and so 14.715. And it sure did take a little while. I had to pause the video. All right, next. We've got a little bit more to go here. I think this is our last one. Okay, let's make it count. The region R is bounded by the graph of f of x equals 4 sine 2x and g of x equals x squared plus 4, the vertical line x equals pi over 4, and the y-axis. First, we're going to find the area of R. So this is R, and it's not, I don't have a pretty little color for it, but they did mention, so I'll highlight it, that we are bounded by the y-axis, so all these lines here. To find the area of R, I simply need to subtract the top curve minus the bottom curve from 0 to pi over 4. So 0 to pi over 4. The top curve is, which one? X squared plus 4. That's the top curve. And then the bottom curve is 4 sine 2x. And we're doing that whole thing, dx. Okay, so to find the area here, I just need to use my integration. I just do x cubed over 3 plus 4x. This is going to actually become plus 2 cosine of 2x. If you take the derivative of 2 cosine 2x, you get negative 2 sine 2x times 2. When the 2's multiply to 4. So I did a little bit of u substitution in my head there. Feel free to do the u substitution, let u equal 2x, and see how that works out. We're doing it from 0 to pi over 4. So then our result is pi over 4 cubed divided by 3. Plus 4 times pi over 4, which is just pi. And the cosine of 2 times pi over 4 is the cosine of pi over 2, which is 0. Then we're going to subtract 0, 0, and 2. And that's our area. Next, the region R is revolved along the line y equals -1. So if we're going to revolve this around the line y is equal to -1, that's down here, then it's going to be moving in this kind of direction like so. So if I was to draw one representative washer, then I would have the center is at -1. The outer radius is the top curve, which is x squared plus 4. So I have x squared plus 4 is the top minus the bottom of the radius, which is a -1, so it becomes a +1, so it's x squared plus 5. The inner radius, again from the axis of revolution to the lower boundary of R, is going to be 4 sine 2x minus a -1, so again +1. So our integration is pi r squared minus r squared. So x to the 5th plus 5 squared minus 4 sine 2x plus 1 squared, and that whole thing times dx. And we could use a calculator to evaluate that. It would be totally possible to do that by hand, but that would be a lot of work. You have to square both of those things, and so I'll leave that to you if you want to figure out what that is. But for now, we're just going to write the expression. All right, the region R is the base of a solid with cross-sections parallel to the x-axis in the shape of semicircles. So we're going to be doing semicircles parallel to the x-axis. So if they're parallel to the x-axis, that means they're perpendicular to the y-axis. So I'm going to need to, let me just grab a quick copy of this. We're going to need to do some fancy algebra footwork here. So what I need to do is find the distance from here to here up until y is equal to 4, at which time, since this has a maximum of 4, you can see that because this curve is, remember, 4 sine 2x. The range of sine is -1 to 1. If you multiply it by 4, it's -4 to 4. So that's what this maximizes at. And this curve has a bottom, a vertex, because it's x squared plus 4 at 4. So we need to switch curves. But I also need to solve these to make them x as a function of y, since we're working with y's here. So let's do that. I get y over 4 is equal to the sine of 2x. So this is arc sine of y over 4 divided by 2 is equal to x. The other equation becomes y minus 4 square rooted is equal to x. And again, it's plus or minus, but we're only in the positive quadrant. So I'm going to integrate from 0 to 4. I'll be using the right minus the left. The left x value is simply 0, so I'll just be using, and these are the shape of semicircles. So actually I need to realize that if this is a semicircle, that I actually need half of this for my radius. So I'll be taking half of that, so that's arc sine y over 4 divided by 2, and then divided by 2 again, so it'll be over 4. So now that's the radius, because it's the diameter is all the way across. Square it, multiply it times pi, and put the pi out here, and divide it by 2, because it's only a semicircle, so we have to divide by 2 twice. I'm then going to add to that the integral from 4 to this y coordinate. So we'll need to solve for that. What is that y coordinate? Well, if we solve the square root of y minus 4 equal to pi over 4, we'll get that y is equal to pi squared over 16 plus 4. And we'll be using the curve. We'll be using this portion minus this portion. So it'll be pi over 4 minus square root of y minus 4. That's the radius. Actually, that's the diameter. So now I need to divide it by 2. Then I need to square it. Then I need to multiply it by pi and have it. Those two together would give me my full volume. Kind of a tough one, but still kind of neat, right? Well, that was it. That was AP Calculus AB. It's been a real pleasure. So good luck on the AP exam.